Hey there, I know exactly why you're here. You're cramming for that IT 2023 exam, right? The stakes are high, and you're probably staring down this massive pile of web architecture notes just wondering how the heck it all connects. Well, take a deep breath. You are in the right place. In this explainer, we're going to strip away all the noise. We're going to give you the ultimate logical blueprint so everything just clicks. By the end of this, you'll be walking into that test with total confidence.
Here's a quick look at our structured syllabus for today. First, the three-tier architecture. Then, we hit the client side with JavaScript and the DOM. Third, server-side core, PHP logic. Fourth, processing and securing form data. Fifth, the database vault with MySQL. And finally, scaling things up with frameworks and CMS. Let's get to it.
All right, Section 1, the three-tier architecture. This is our blueprint.
Okay, let's dive right into this. To understand modern web applications, you absolutely have to understand their foundation. Every single modern enterprise web infrastructure relies on the three-tier architectural framework. It's an explicit structural breakdown that isolates operations into three distinct layers to scale things up and protect records. Think of it kind of like a restaurant. The presentation tier, that's your dining room. It's what the user actually sees, built with your HTML, CSS, and JavaScript. Then you have the logical tier, which is the kitchen. That's the application side, running on servers, using languages like PHP to cook up the business rules. And finally, the data tier. That's the locked pantry in the back, your structured relational database like MySQL, keeping your raw records completely safe and away from the public floor.
You can see how this exact breakdown perfectly isolates our web concerns. We've got interface layouts handling the graphical side right in the browser, the execution rules happening dynamically at runtime on the server, and then the persistence repositories acting as the storage engine. This separation, it's exactly what allows enterprise systems to scale operations completely independently, and, most importantly, it protects your critical data.
Okay, major exam alert here. You really need to lock in the difference between these two paradigms. Programming languages, think C++ or Java, require ahead-of-time explicit compilation. They generate low-level binary machine code before they even execute. They're completely standalone ecosystems. Scripting languages, on the other hand, like JavaScript or PHP, are totally different. They're lightweight. They get read, evaluated, and executed row by row, totally on the fly at runtime, by an interpreter engine. You'll usually find them embedded directly into other environments, like an HTML text stream.
Moving on to Section 2, Client Side, JavaScript and the DOM, the front lines.
Let's transition our journey straight into the user's browser. These are the front lines, where dynamic layout behavior happens instantly without any annoying server delays. When an internet browser requests an HTML sheet, again think of it like reading the restaurant's menu, it builds an in-memory object tree. We call this the Document Object Model, or DOM. JavaScript actually uses this structured map to rewrite styles, text fields, and elements entirely on the fly. It is literally what makes a web page feel alive and interactive.
For your exam, you absolutely must know your core DOM toolkit. These are your must-knows for structural manipulation. First, you have to find your target, right? You use document.getElementById for a singular specific node, or document.getElements by tag name to extract an array of elements. Once you've got your target, you can change it. Use element.innerHTML to inject new data, or build entirely brand new markup from scratch using document.createElement and append child. Nail down this structural manipulation and you're going to ace those client-side questions.
All right, Section 3, Server-side, Core PHP Logic. Welcome to the engine room.
So we're leaving the browser, crossing over the internet, and entering the server's engine room where strict business logic is driven by PHP. Now, what's really interesting about this, and watch out because this is a classic exam trick question, is the execution order. You need to know the exact difference here. A standard while loop evaluates its test criteria before it runs any code whatsoever, but a do-while loop, it guarantees that the inner target block will run exactly once before it evaluates the condition at the trailing boundary. It always runs once. Don't let them trip you up on that.
Another absolutely critical syntax rule in PHP revolves around string evaluation. Single quotes are strict and literal. Whatever you type inside them prints exactly as is. Variables? Totally ignored. Double quotes, however, bring things to life. They evaluate inputs dynamically through string interpolation. That means PHP will actually identify internal variables, parse their true underlying values, and inject them directly into the output string.
Section 4, Processing and Securing Form Data. defending the engine room.
When user payloads from a web form finally hit this engine room, they have to be treated immediately as a potential threat. So the crucial point in defending it is understanding exactly when to use our HTTP request paradigms. The GET method appends parameters visibly right there in the URL. It has strict character limits and it's fully cacheable. It's best for non-destructive actions, like a search bar filter. POST, on the other hand, packs transaction inputs cleanly inside a hidden payload body. It supports unlimited sizes and it cannot be bookmarked. You use POST for secure, state-altering mutations, things like user registration or password submissions.
I cannot stress this enough. Never, ever trust unverified user form inputs. Attackers will absolutely exploit raw forms using cross-site scripting, or XSS. To stop this cold, you need to memorize this exact three-step defensive sequence. Major exam alert here. First, trim to strip any accidental bounding white space. Second, strip slashes to remove escape backslashes. And third, HTML special cares. This is the big one. It neutralizes dangerous script tags by converting them into safe, completely harmless entities.
Moving down to Section 5, the Database Vault, MySQL, the persistence layer.
We're descending even deeper into the data tier now, reaching the persistence layer. This is that locked pantry where raw entity maps are stored completely away from the public web exposure path. Now, when integrating PHP with MySQL here, you have to recognize two distinct legacy implementation patterns. The procedural model relies on explicit functions passing the connection variable, like MSI QS then underscore connect. The object-oriented model instantiates a new object using new MSI QI and uses arrows to access methods and properties. Just be ready to visually differentiate which is which on the test.
Now, the modern standard for database connections today is PHP Data Objects, or PDO. And this brilliantly illustrates how it's an abstraction layer wrapped cleanly inside defensive try/catch blocks. The flow is simple. You establish the link via a specific PDO DSN string. Then, you execute your SQL query statement. Next, you process the records iteratively using associative data mapping. And finally, you cleanly terminate the active database pointer. It's safe, it catches errors before they leak server configurations, and it works across multiple database types.
Finally, Section 6, Scaling, Frameworks and CMS. Let's look at the big picture.
Zooming out from all that raw code, we really need to look at the strategic big-picture architecture of how enterprise applications actually deploy and scale safely out in the real world. First up, we have Web Application Frameworks, or WEF. Think of tools like Laravel or Symfony. Frameworks abstract away all those low-level plumbing complexities, things like database connectivity and session management, so developers can focus directly on business requirements. They massively accelerate development velocity and provide robust out-of-the-box security patterns. But the trade-off? You get execution overhead, a really steep learning curve, and rigid boundaries that can make low-level customizations kind of tricky.
Next, we have Content Management Systems, or CMS. These are designed specifically to organize and edit text assets and images without forcing manual HTML code updates. A good CMS gives you incredible advantages like easy deployment, semantic SEO, and system-wide styling consistency. However, you have to carefully weigh those conveniences against the serious drawbacks. We're talking core security risks from vulnerable third-party plugins, bloated markup that gets injected by WYSIWYG-rich text editors, and the reality that proprietary systems can totally lock you to a specific infrastructure host.
And that, my friends, brings us to the end of our architectural masterclass. You now have a structured, comprehensive grasp of the entire web environment, from the browser DOM to PHP logic, secure data processing, and database persistence. You are absolutely ready to crush this exam. But as you continue to study, I want to leave you with this final, provocative thought. As powerful abstractions like enterprise frameworks and CMS platforms increasingly hide the underlying code, do you think the strict boundaries of our beloved three-tier architecture will evolve, or perhaps eventually disappear entirely? Keep that in mind as you step into the future of web engineering. Best of luck on the test, you're going to do great, and keep learning.